Okay, with our warm-up to graph the sine function, we want to identify a, b, h, and k. And if you need to, you can always kind of set up this. Actually, I usually put b right outside. You can set up the values. And we had kind of talked about b was really the only thing that's officially new to us. Everything else kind of was present in other functions we studied. So a is 3, the b value is 4. The h value, there is no add or subtract right after here. You could write a plus 0, but the h is 0, which means there is no phase shift. We're not going to move left or right. And then the k value tells us to shift everything down 1. And that k value, remember, is your midline. Okay, so then we want to kind of take the idea, all right, well, what is the amplitude? The amplitude is the absolute value of whatever a is. So that's 3. And that's going to tell me how high and how low I go from the midline. So maybe before we do anything else, let's graph the midline at -1. So before I do that, I usually, with trig functions, I don't actually like to use graph paper. I just go ahead and make 4 tick marks to the left and 4 tick marks to the right, and then however many I need vertically. Now I know my amplitude is 3, so I know I'm going to have to be up and down 3 from the midline, and my midline is at -1. So I need to be 3 up from that and 3 down from that. And then let's just put our midline in. I'll position that correctly. And it is important for you guys to be able to understand and know where that's located. Right? So I would label it, my midline is at the equation y equals -1. Okay, so there's the midline. It's a weird way to spell line. And then from there, we can do our amplitude, right? The amplitude is how high up and down I go. So the amplitude is 3 up from the midline and 3 down. Well, if I go 3 up, here's 1, 2, 3. That puts me at +2. You can draw your dotted line there. And then we should label that. That's the max line at y equals +2. And the minimum line is 3 down from that. So that goes 3 down from the midline would put me at -4. That's where the minimums occur. And they all occur at the equation y equals -4. All right, so now we have max and mins. The only other thing I really need is I need to figure out this period. And the period was always, for any sine and cosine function, it was the equation 2 pi over the absolute value of b. Well, we know b is 4. So if I do 2 pi over 4, that reduces down to a 1/2. So this one is a little bit interesting. It's saying that the 4 kind of speeds things up, and it's going to make this occur instead of going all the way to 2 pi. The 4th tick mark is pi over 2. So if I go 4 tick marks to pi over 2, well, what would half of that be? If I cut that in half, that's like timesing by 1 over 2, so this would be a 4th. And if I cut a 4th in half, that means every tick mark is 1/8 of pi. So this would be 1/8 of pi, 2/8, but that reduces down. So I know that this one would be 3/8 of pi. And that's going to tell me where my max, minimum, midline all are. Now I do want to also graph to the left, and notice if every tick mark is pi over 8, then I can just mirror these images, but instead of going to the right, it's negative. So that's -1 pi over 8. This would be -4 pi. negative 3 pi over 8, and then negative pi over 2. Okay, so we have our period. That period basically gives us these values here. We applied our vertical shift. The vertical shift was negative 1, right? That shifted everything down 1. Now I have everything I need. I just have to graph. So let's pick a color that'll show up here. Maybe yellow. It's a sine function. Yellow is not the choice. Let's do green. Where does sine start? Sine always starts at the midline. I'm going to go to the midline, then the next tick mark over would be up to the maximum. And then I go back to the midline. I want a better color. Let's do red. So start at the midline, maximum, minimum, midline, minimum, and then right back to the midline. And that's one period worth of sine. Okay. And then it keeps going, so I'm just going to draw arrows. Now, I do also want to graph to the left. Well, all this is following is the pattern. I went maximum midline, so then I'd have to go down to the minimum at the next tick mark, and then I'd go up to the midline again. The next tick mark over would be the maximum, and then back to the midline. And that would be the second period of this function. Okay, so hopefully you can kind of check that off. In my mind, if you can do that, the only way this gets more challenging is if I had an h value. And all the h value does is shift where I start. So like, let's say that I had a minus pi over 8 here. If h was minus pi over 8, that means I would start at negative pi over 8. And that would just take this shift and move it over. So all these points would shift to the left, 1. And that's all h does, is shifts to the left or right. Which is kind of why it's important to see these, what each value is. Pi over 8 is every tick mark. Okay, so hopefully you can kind of check that part off and give yourself confirmation of I know how to graph, sine, or if it was a cosine function, the only difference is instead of starting at the midline, a positive cosine function starts up top. And then you go minimum, or midline, minimum, and follow the pattern. All right, what I want to do here is go over these, evaluate the following trig functions using the unit circle. And hopefully you're using it from your brain. But I'm going to just kind of quickly do these to show you how I would think of it using and making reference to the unit circle. This is the thing that I notice on all the delta math problems. When you had a problem like this and they gave you the circle, a lot of students were leaving this blank. Either you're getting it wrong, or one of the things that I found out is that photomath does not do these problems. So that might be a reason why. And if that's the case, I would throw a huge caution out there for some of you that are relying on photomath to answer problems. I don't know who that is, but I do know what's happening. So anyways, what are we thinking of? I need cosecant of 135. Well, the first thing is I have to figure out where is 135. Well, here's the way my brain works. I know that this is 180, halfway. So if I take 180 minus 135, what's left over is 45. All right, so then I'm going to go 45 degrees from this x-axis. But that would put me right here. Here is 135 degrees, right? If I graphed from here to here. But what we want is we know that this is a 45-degree reference angle right here. And I know that cosecant is the reciprocal, actually maybe I'll write it here. This is the reciprocal of sine. Well, sine, if you remember, when we had the ordered pair here, sine was always the y value. So this is the same as 1 over y. So if I can figure out what the y value is, I'm going to just put it here and then simplify. So that just means I need to figure out what is this triangle right there. Now, what I would do is I would actually make reference to the 45 degree, because we said if you can memorize quadrant 1, the only difference between this quadrant and this quadrant is the x values are negative. So in a 45, 45, 90, this was at the spot square root 2 over square root 2. And that came from memorization of the first quadrant. Now notice, that's x and that's y. Well, x is positive because I moved to the right, and y is positive because I moved up. So both of these are positive. Well, the location over here now, if I move to the left, that's a negative x value, and if I move up, it's a positive y value. So I don't have a ton of room right here. I make this bigger. So I know that I went to the left, negative square root 2 over 2, because this triangle is the same as this one, so its coordinate points are the same. The only difference is this is a negative x and it's a positive y. So now I know what the y value is, and if cosecant is 1 over sine, that's 1 over y. So I'm going to put square root 2 over 2 right here. And then I just need to simplify this and write it in reduced form. So this goes back to just fractions. We don't like to divide by a fraction, so we multiply by the reciprocal, which means I take the one that's up top, and then I'm going to multiply by the reciprocal of the denominator. You can think of that as 1 over 1. Well, what does that do? That gives me 2 over square root 2. And then I just have to get rid of the denominator in the bottom by timesing by the square root of 2. So I get square root of 2 over 2 square root of 2 over, remember this is the square root of 4, but the square root of 4 is 2. And then you have a 2 and a 2 here that'll reduce out. So my final answer is just square root of 2. Okay? Not easy. It takes practice. It takes skill to become really good at this. And actually, the more you do, the more work you can skip. And you could most likely go from right here to right here. And you know this answer without showing any of this work. And if you can do that, great, do it. That's the goal, is to evaluate these trig functions as fast as you can, but also accurate. All right, let's look at, now we're in radians. So I've got 7 pi over 6. Well, if I have my unit circle, and that's a circle, I know that this is pi, right? Halfway around is pi, but I'm not going to think of it as pi. I'm going to think of it as 6 pi over 6 pi, right? Those reduce out, so that's pi. All that means is I'm going 7 pi over 6. I'm going 1 more pi over 6 past that. So here's the way my brain works. A pi over 6 is an extra 30 degrees. So this triangle, the reference triangle, has a 30-degree angle right there. Well, what I want to do is I need the location, I need the coordinate of those points. I need the xy value. Those points are the same value but different signs as the 30-degree triangle in quadrant 1. So here's the way I think of this. Quadrant 1, x and y are both positive. And I went over the long distance, which memorization tells me it's square root 3 over 2. And then I'm going up halfway, and my drawing isn't perfect. If it was, this would be the halfway y value up here. So that's 1/2. Well, now, if I know those points in quadrant 1, then all I have to do is think about what's in quadrant 3. Well, the x is negative and the y is negative because I went to the left and down. So I get negative square root 3 over 2 and negative 1/2. And then I just have to think of, all right, well, I know what x is, I know what y is. What is secant? Secant is the reciprocal of cosine, and cosine is always the x value. So secant is 1 over x, which 1 over x, the x value is negative square root 3 over 2. Something is wrong with my computer's like trying to keep up with I think everything that I have going on, so my writing is extra sloppy today. All right, so now I just have to get rid of, I have to simplify this. I like to think of it as timesing by the reciprocal. We don't like to um, divide by fractions. So I'm going to flip this upside down and now multiply straight across, which is just really 2 square roots of -3. And then we run into that same problem where we don't like the radical on the bottom. So I just have to multiply by square root of 3 top and bottom. So I get 2 square roots of 3 over square root of 3, and square root of 3 is square root of 9, which is 3. And then this negative, I like to put it up top. It doesn't really matter, but that's as far as we can go. And when doing the unit circle, this is about as messy or as ugly as these problems get. Square root of 2 square root of 3 over 3. All right, last one, cotangent. Cotangent might be the most challenging. Depends on how you think of it. So hopefully you're seeing how everything we've learned this unit is pieced together, right? The important thing is, okay, first off, where is 5 pi over 3? Well, if I had pi, I could change that to 3 pi over 3. So that means that here's 1 pi over 3 right here. Here's 2 pi over 3. Here's 3 pi over 3. See how I split pi into thirds? And then 4 pi over 3 would be somewhere here. 5 pi over 3 would be here. And 6 pi over 3, 6 pi over 3, that divides out. That's 2 pi. That's all the way around the circle. So that's how I know where 5 pi over 3 is located. Okay, so if I went all the way around the circle, 5 pi over 3 would get me right here. Now, that forms a reference angle. And this reference angle is the same as the one in the first quadrant, which is just pi over 3. Pi over 3 is a 60-degree angle, so this is 60-degree reference angle. So then I'm thinking, okay, this is the shorter distance and the taller value. So that means I went over 1/2 and I went up square root 3 over 2, which if you've memorized just the values in first quadrant, then you can just reflect this down. Thought I could move that. I'll do this in a different color. So then I know the location of this point is at over 1/2, because I went over to the right, so x is positive, but now I go down. And if I go down, that just means the negative square root 3 over 2. So there's x and there's y. Or again, you can think of it as cosine and then sine. So how do we think of cotangent? That's the other question, is what is cotangent? Well, cotangent is 1 over tangent, and tangent was always sine over cosine, right? So I might write that over here because this is the way my brain works. I know that tangent is sine over cosine, so that means cotangent of theta is cosine over sine. My pen is really acting up. Okay, so this right here, 1 over tangent, is the same thing as the reciprocal of tangent. Well, cosine is the x value, so some people memorize cotangent as x over y. But there it is. We're just going to do x, which is 1/2, over y, which is negative square root 3 over 2. And this is about as nasty as it gets, a fraction divided by a fraction. So then I just want to take this, and I don't want to divide by a fraction. I want to take this and multiply by the reciprocal. And when you do that, you'll notice the 2's go away, right? A 2 on top and a 2 on bottom go away, and I'm left with 1 over negative square root 3. And then the final piece is we just don't like to have that square root of 3 on the bottom. So I'm going to multiply, this is called rationalizing the denominator. I'm going to multiply by a square root of 3, and up top I get 1 times the square root of 3, which is just square root of 3. And then on the bottom I get square root of 3 times the square root of 3, which is the square root of 9. But we know the square root of 9 is 3. And the negative, I like to put it up top, but it doesn't really matter. Okay, I tried to pick kind of 3 of the nastiest ones. And if you were able to do some of these or all of them successful, I think you're in a good spot. Okay, hopefully we showed you a couple things, and notice we didn't use a calculator, we didn't use any other options. All right, so we're going to try something a little different here today. What I'm going to ask you to do is I'm going to give you a YouTube link in the chat. So open up your chat right now, and we're going to watch a 12-minute video on graphing tangent functions. And then I'll have you come back. You don't have to take notes, just sit back and watch it, okay? And you can log off of Zoom if you want right now, and then log back, and we'll come back at, let's say, 10:13. All right, so definitely watch this video. It's in the chat, and we'll come back at 10:13. And then I'll take attendance. What I want to do right now, really quick, is I want to make sure you understand what we're going to do on Pear Deck so you can kind of see what's going on. So when you get that link, you'll open it and answer how you feeling today. Oh, apparently, small error. Let's see what happened. Let me try this one. Okay, so I'm just going to click on how I feel, load the presentation. And then you can't progress on this because we're going to do it together. But what I want to show you is as soon as this allows me to. Okay, so don't write anything on this if you have it open. We'll come back to it. I just want to show you how you can manage this. Now, this was from Ms. Dwyer. If you want to follow her steps, you can, but we kind of talked about this in general. She's very specific to how she wants her midlines colored. I don't really care, but if I follow it, my goal is to graph 3 tangent of x. And what a hint for you is you can use the line feature and then select the color. And if I have tangent, the midline for tangent is basically this, but look how wide that line was. So what you can do is you can go up here and change your sizer. And I want to just bring that as low as I can go. Now I'm going to erase this line, which, by the way, notice if I do this with the eraser, that gets me dotted lines. So, or I could hit undo, and that will basically let me start over. Or you could hit clear, and that'll clear everything. So, I just want to show you this quick. So what I want to do is I want my size to be small, as small as possible. And I'm going to go to line. I want the blue line. I'm just going to draw a straight line. That's my midline. And then if you want to make it dotted, you can just use your eraser to dot it. So there's the midline. And then we want the red line is the phase shift. But you'll notice tangent here doesn't have a phase shift. So then I'm going to draw my line here. I'm not super concerned. Making it dotted is fine. It's not super straight, but that'll work. And then you can go ahead and for here we got our boundary lines in green, and you want to figure out where that is. So we'll go over this, but I just wanted to show you quick. If you want to make lines, you can go like that, or you can dot it however you want to do it. But if you change the sizer, that will make things go much faster. And then if you want to plot points, randomly, you can change the sizer again and just use those to plot points however you feel the need. So what I want you to do right now is I want you to try this. And I just want to see where you're at. I'm going to double check that I've got people on here. So if you didn't get a chance to, open up the link now to PreCalc. Okay, so what do we have? We've got 3 tangent of x. Now, tangent is the same as sine and cosine in terms of determining what a, b, h, and k are. So my a is 3. The b value you can always sneak in front. Think of that as like a 1 here. And then you don't have any values being added or subtracted for h, and same thing for k. You can always put a 0 here and a 0 here if you want. But that tells me there's no shift left or right, and there's no shift up or down. So the only thing that the b does is b controls the period. And tangent has a different period than sine and cosine. It's pi over b. So if I do pi over 1, because b is 1, that tells me that my length of tangent's period is pi. Now, Ms. Dwyer in the video talked about that means the full length centered on the origin has to equal pi. Now, she talked about counting boxes, and I think about it as just tick marks. But if you took pi and divided it in 2, pi divided by 2 tells me where the intervals are going to be. Right here at pi over 2, and then right here at negative pi over 2, that's where I'll have my vertical asymptotes, because that's where tangent is undefined. So then, the quick way to graph this was if you start at the midline, that's the first point of tangent. When x is 0, tangent is 0. And when we go over the first tick mark, we go up whatever the a value is. Well, in this case, the a value is 3. So I'm going to go over 1, up 3. And to the left, we go over halfway and down 3. And then that graph of tangent kind of has this little curve to it. And think of that that 3 as just a vertical stretch. So now I could mimic this same thing over here. I would just count how many tick marks are between the 2 lines. There's 4 of them. So I would pull this line over 1, 2, 3, 4, and then everything else would repeat. Right? So then I'd go right in the middle. That's where this spot is. That's 4 units over. And then I'd go over 1, up 3, over 1 the other direction, down 3, and there's the second branch of tangent. Okay? Now, I could repeat this as much as I want to the left and to the right, and it looks like we had a handful of people doing that. So, I have good news for you. We are not going to be doing a lot with tangent. We wanted you to just watch a quick video on it and see that, you know what, its graph is slightly different than that of sine and cosine, and the reason why is because if you think of the unit circle, there are values at which tangent is undefined. So just be careful on that. This graph is not go left to right as like a smooth, continuous function like sine and cosine. Okay? I'd like you to try one now with, and I believe you should be on here. So if you go back to PreCalc, I'd like you to try this one here quick. This is just 5 sine of x. So here's how I graphed the 5 sine of x. The amplitude is 5. B is 1, so my period is 2 pi. So that means my 4th tick mark over is 2 pi. And you could use, Ms. Dwyer talked about if you wanted to go 8 tick marks, then you would have to just map this differently. So I'll show you how I would do that on this one if I wanted 8 tick marks instead of doing 4. I just would skip every other. So 1, 2, 3, 4, 5, 6, 7, 8. That would be at 2 pi. So then half of that would be 1, 2, 3, 4. So that's pi. And half of that would be pi over 2, and then 3 pi over 2. So it just extends it out, which is completely fine. And then sine starts at 0 and it goes up to the maximum. Now here's where I have to be careful. If I use 8 tick marks, then I got to go up from the quarter mark, which is 2 tick marks over. And then I go to pi. 3 pi over 2 is at the minimum, and 2 pi is at the midline, and then we graph it again. Okay, so nothing super special. I just kind of wanted to show you that. We're going to X out of the pair deck, so you can leave that alone. We didn't get through all of them, which is fine, but I do want to show you this last piece here, and it's on delta math. So I want to show you how delta math works because you could have a question on it. So the homework tonight is 4-4 day 2, and I want to show you some of the skills here quick. So the first one is just matching. It's looking at a function. You're going to determine first off of the base, the midline, and then you have to compare the period. So there's videos if you need to help on this one, but you're basically looking, all right, is this a sine, cosine, or tangent? And a lot of times where the value starts can give you a good sign. So in this problem, I would notice that I start at the minimum, which means it's a cosine value, but starting at the minimum means it's negative. So my A value is negative, and it's definitely a cosine. And then the question is, all right, the midline is 300. So what is the period? And that's where you would have to take this value and find the period and then match that with the period here. Okay, so nothing special on that one, but I want to show you this part here because this is where it gets tricky. So it says on the graph below, we want to put an approximate scale and then graph exactly one cycle of the trig function. So watch what happens here. I'm going to graph 7 cosine of 6 pi. Well, the first thing I need to do is find that period. And if I do this, this would be my separate work here. I would say, okay, if y equals 7 cosine of 6x and the b value is 6, it's a cosine, so I'm going to determine the period first. And I'm going to say 2 pi over 6 tells me the period is pi over 3. Okay, and you could actually type in 2 pi over 6 if you wanted, but watch what happens. So when I type this in, my period is pi over 3, and that's the x value. So I'm going to put pi divided by 3, and then my y values is going to be how high do I want to go. So I could call it 1, because if I call it 1, then I can go up 7 and get the amplitude. So once I set the x and the y-axis, remember the x-axis is the period, I'm going to click done. And now you have to plot points. So I'm thinking, all right, where does cosine start? Well, cosine, we have to plot the points. So I'm going to start, cosine is up at 7. So there's the start. And then the next tick mark down would be here at 1 value. And then I would go down to -7 because that's the amplitude. And then back to the midline and back up. Now, I believe so now look at this. See where it says x is pi over 3? I need to drag that point to tell the person reading this that this one cycle of cosine ends at pi over 3. So if you want to pick 8 boxes, you could, and you would just move this dot to the 8th box, and then you would have to go. I recommend doing the just every 4th box is your period. Then hit submit, and it works. So let me show you another quick one. Like here, if I do 7 pi, now notice, if you wanted to, you could say this. Right away, I know the period is 2 pi over whatever the b is, and b is 7 right here. So I'm going to go just 2 pi over 7. It doesn't reduce, so I don't need to reduce it. And then what's my x value? I'm going to just say 1, because that's easy. Sometimes, let's say this was like 17. Well, I don't have 17 tick marks, so then I might have to go by 2 or by 3. But once you set that, here's my little dot to move to the 4th tick box. So 1, 2, 3, 4. There's the 4th tick mark. That's going to be 1 cycle. And then I have an amplitude. So now I'm just going to plot the rest of my points. So sine starts at the midline, and then the first tick mark over goes up to the max, and then it goes back to the midline, and then it goes down to the minimum, and then I return right back. And there is the 1 cycle of sine, and notice that it ended at 2 pi over 7. Okay, so that's just tricky. I wanted to show you that so you guys get an idea. But that's the homework today for 4day 2. There is no tangent on there, which is fine. We just wanted to expose you to tangent so you knew what it looked like, but that's something we're going to kind of skip, and it will not be on the test. I do want you to note the Chapter 4 test is next week, Thursday, because we have class on Monday and Thursday next week. All Chapter 4 homework is due by Wednesday, February 3rd. So some of you have a good amount of missing work. Please plan accordingly. I'll be in my office hours today. If you need any help, stop on in and we can go over anything you need to talk about. So that's all I have for today. Have a good one. Enjoy the weekend. We'll see ya.